Today's video is going to talk about factoring when you have a difference of squares. First, we're going to look at multiplying two things that give us a difference of squares. So the first example, first of all, when you multiply two binomials, you do something called the FOIL method, F-O-I-L. F stands for first terms, so the first term times the first term. X times x gives us x squared. O stands for outside terms, so we'll multiply the outside terms together. That's going to give us negative 4x. I stands for inside terms, gives us positive 4x, and L stands for last terms, which gives us negative 16. Then whenever we simplify what we have and combine like terms, we're going to get x squared, but then negative 4x plus 4x is just 0. So then we have minus 16. And if you look, difference means subtraction. We have that. And squares means that we can take the square root of those things. And x squared is a perfect square because the square root of x squared is just x. And 16 is a perfect square because the square root of 16 is 4. So let's walk through a couple other examples and just see how this pattern holds up. So 5m times 5m, well, before I do that, another way to think of the FOIL method is just distributing both terms. We distribute the 5m, then we distribute the positive 1. Either way you want to look at that is fine, as long as you remember that when you multiply two binomials together, you should always get 4 terms. They'll simplify, but you should always get 4 terms initially. Okay, 5m times 5m is 25m squared. 5m times negative 1 is negative 5m. 1 times 5m is positive 5m. And 1 times negative 1 is negative 1. Again, our middle terms will cancel. We get 25m squared minus 1. All right, on the third example, 2a times 2a is 4a squared. 2a times negative 3b is negative 6ab. 3b times 2a is positive 6ab. And 3b times negative 3b is negative 9b squared. Again, our middle terms will cancel. This does not happen with every single multiplication of binomials. This only happens because if you look at these binomials, all of them that we've multiplied together, sorry if you just heard my dogs in the background, they went a little crazy. But anyway, back to math. If you look at all the sets of binomials that we've multiplied together, they all have something in common. The first terms are the same and the second terms are the same, but one is positive and one is negative. That's the same for all 3 examples. That is the reason that our middle terms cancel. If that's not the case, then these are not going to go away. So you can't just assume that every time. Okay, anyway, this simplifies to 4a squared minus 9b squared. So all 3 of these things are difference of squares because they're all subtraction and all the terms are perfect squares. These over here are what our answers will look like whenever we start factoring. If you notice, the square root of x squared is x. The square root of 16 is 4. And then we have 1 plus and 1 minus to make our middle terms go away. The square root of 25m squared is 5m, which is for both of the first terms. The square root of 1 is just 1, which is both of these terms. And then we have 1 plus and 1 minus so that our middle terms will disappear. And the same is true for the third example. So let's begin looking at examples. First, I want you to go to the part of your paper that shows the rules, or not the rules, but the steps. And the rule that we're going to use is that a squared minus b squared equals a plus b times a minus b. And then, so we're going to factor, and then we're going to check our work by distributing. Before we can factor, we have to make sure that we have a subtraction sign and we can square root both terms because that's the only way that these are actually a difference of squares and we can even use this rule. So number 1, The square root of a squared is a, so it's a perfect square. The square root of 4 is 2, so it's a perfect square. We have subtraction, so we have a difference, and we are ready to use our rules. Now, the formula that it gives you here, yes, that's true, it's accurate, whatever, but in my opinion, the easiest way to approach these problems is to first set up your parentheses with a plus and a minus, because we know that a difference of squares will factor to something that looks like this with these blanks all filled in. And then we take the square root of a squared. That's just a. That will be our first term in both binomials. Then the square root of 4 is 2, which will be our second term in both binomials. We check our work by distributing, or the FOIL method. So a times a is a squared, a times negative 2 is negative 2a, 2 times a is positive 2a, and 2 times negative 2 is negative 4. This will simplify to a squared minus 4, which is what we started with, which means we did get the correct answer. So we're going to skip down to number 6. The square root of 1 is 1. The square root of 49y squared is 7y. And this is a difference. So we are okay to use our rule. Now we're going to set up our binomials. So we'll have one with a plus and one with a minus. The square root of 1 is 1. So we will put a 1 in both first terms. The square root of 49y squared is 7y. So that's going to be both of our second terms. To check our answer, we use the FOIL method. 1 times 1 is 1. 1 times negative 7y is negative 7y. 7y times 1 is positive 7y. And 7y times negative 7y is negative 49y squared. Again, our middle terms cancel, and you'll see that what's left is what we started with. So that means this is the correct answer. Now we've skipped down to number 19. We have 121r to the 6th. 121 is a perfect square. The square root of it is 11. And r to the 6th is a perfect square because we can do r to the 3rd times r to the 3rd. When you multiply with the exponents, you add them, and this equals r to the 6th. So when you take a square root of something with an exponent, you divide it by 2. Divide the exponent by 2. And in that case, that means that if we have an even exponent, we will always be able to take the square root of it. If it is an odd exponent, then we will not be able to take a square root. So we know that 1 is also a square, a perfect square, and the subtraction sign makes it a difference. So let's set up our binomials for our answer. We will have one positive and one negative. And the square root of 121r to the 6th is 11r cubed. So that's our first term for both binomials. The square root of 1 is just 1, so that will be our second term for both binomials. Then we check our work. 11r cubed times 11r cubed is 121r to the 6th. 11r cubed times negative 1 is negative 11r cubed. 1 times 11r cubed is positive 11r cubed, and 1 times negative 1 is negative 1. When these cancel, you'll see that what's left matches what we started with, so this is the correct answer. Now number 26. This is an example with a greatest common factor, meaning that if you look here, we have b cubed. That is not an even power, so we can't take the square root of that, even though 136 are both perfect squares. So if we look at this, 136, those are both divisible by the number 4. So even though they're perfect squares, we need to take that greatest common factor out, because if we don't, then what's left inside of our binomials we'll be able to take more factors out, so it won't be finished. So we're combining what we did with greatest common factors now with perfect squares. So anyway, we take a 4 out because 136 are both divisible by 4. B cubed and b, we can always take the smallest exponent worth out, so that's just going to be b. Then what's left inside is going to be 25b squared minus 9. So this is now a difference of squares. So what we're going to do is our greatest common factor stays on the outside, and then we set up our parentheses the same way we have been. But we're only looking at what's left down here. We don't care about this anymore. Does not matter. So the square root of 25b squared is 5b. That's our first term for both binomials. The square root of 9 is 3. So that's our second term. So this is the answer that we're going to check. And it's a little more complex than the ones we've done before. So 4b times 5b plus 3 times 5b minus 3. There are two ways to approach multiplying this, and I'm going to show you one way on this problem and another way on the next. So the first way I'm going to show you is to multiply the two binomials first and then distribute 4b throughout your answer. So we keep 4b on the outside. 5b times 5b is 25b squared. Since these are both the same except for the middle sign, we know that our middle terms will cancel, so I'm going to skip that part. 3 times negative 3 is negative 9. Then we would distribute the 4b to both of these terms. That's going to give us 100b cubed minus 36b. That is what we started with, so that means this is our correct answer. All right, the last example I'm going to do with you today is number 28. So we're going to take out a greatest common factor again. This actually tells us that we need to do that, so that should be obvious on these. 8 and 32 have a greatest common factor of 8. So we can take 8 out of both of these. X squared is here, but there's no x here. So we cannot take an x out. Y and y cubed, we can take y out. So 8x squared divided by 8y leaves us with x squared. Negative 32y cubed divided by 8y gives us negative 4y squared. So we can take the square root of this and the square root of this, and this is a difference. So we have a difference of squares, and we can use our rule. So we're going to set it up. 8y times our two binomials. One's going to be plus and one will be minus. The square root of x squared is just x. The square root of 4y squared is 2y. So this should be our answer, but we want to distribute to make sure. So I told you I would show you two ways, so I'm going to show you the other way to check this. In this one, we are going to distribute this to the first binomial. You do not distribute to both, only to one. 8y times x is 8xy, and this answer has to go in parentheses. 8y times 2y is 16y. And then we have our other binomial. And now we will FOIL this. So 8xy times x is 8x squared y. 8xy times negative 2y is negative 16xy squared. 16y times x is positive 16xy. Okay, I just realized I made a mistake in checking my answer, so I'm so sorry, but I'm just going to start this over. All right, so when we check our answer, apologies, we're going to distribute the 8y to the first binomial. So 8y times x is 8xy. 8y times 2y is positive 16y squared. That's what I forgot. I forgot to square the y here. And then we're going to multiply that by the second binomial. So now, whenever we do this, 8xy times x is 8x squared y. 8xy times negative 2y is negative 16xy squared. 16y squared times x is positive 16xy squared. And then 16y squared times negative 2y is negative 32y cubed. So if you look, these two terms are going to disappear. They're going to cancel. And so 8x squared y minus 32y cubed is what we started with. So this is the correct answer. All right, that's all for today. Thank you so much for listening.